All right, we are going to start by talking about exponents. And just like everything in math, it's full of terminology. There are all sorts of words that you're going to need to know when dealing with exponents. And so the first thing I'm going to do is I'm just going to draw out, a typical mathematical expression that involves exponents. And what you see here is a 4 and then a 3 up above it. And we call the bottom number here, so the main number, we call this the base. Right? What we're doing is we're talking about the 4. And then we call this up here, we call that the exponent. And we always ask, what does that mean? Right? What does this notation mean? Math, algebra, pre-algebra, it's all about notation. Right? How do we write these numbers? And what does it mean? So 4, we say this, 4 to the third power, right? And it's another way to sort of state the exponent as a power. 4 to the third power means 4 times 4 times 4. And we also know we can write multiplication as 4 times 4 times 4, or we could even put it in parentheses, right? So look at these, more notations, all different ways to write the same thing, 4 times 4 times 4. So that's what it means. In fact, when we're speaking with exponents, when we're talking about exponents, we really refer to this as expanded form. And that makes sense, right? We take the exponent notation, which is sort of a condensed notation, and we expand it to what it actually means. Well, then we're going to introduce a new word, which is evaluate. You're going to see this word all the time. Evaluate. And right in the middle of the word evaluate is the word value, right? Value. Evaluate means find the value of. Evaluate means find the value of. Whatever comes next, right? Find the value of whatever thing comes next. That's what you typically traditionally done in math classes. When you're given a problem, you have to do some sort of calculation, right? You're given a problem and you say evaluate it. It's like find what it equals, right? So 4 times 4 times 4 equals, 4 times 4 is 16, 16 times 4 is 64. So we would say that 4 to the third power evaluated is 64. There you go. So let's scroll down here a little bit and look at something else like that. So let's say now we have 5 to the second power, right? And if we want to evaluate this, we can, you can think about it as what it means. So think 5 times 5, and then evaluate, and it equals 25. Well, what about something like this, 7 to the first power? 7, we don't really have to multiply it by anything. It's just a single 7 that exists there. 7 to the first power is equal to 7. That's it. I'm going to do one more, and I'm going to put a little asterisk, a little star next to this one, star, and I'm going to do 9 to the 0 power, right? 9 to the 0 power. And right now I would suggest pausing the video and just taking some guesses. Think, what do I think this might mean? And then I always encourage my students to look it up, right? After you've taken a guess, look it up, read about it, see if you can find some information about it, and then come back here. So what I'm going to say now is what you would do, what we would listen to after you have taken a couple guesses. 9 to the 0 power is equal to 1. 5 to the 0 power is equal to 1. 17 to the 0 power is equal to 1. 1 to the 0 power is equal to 1. So anything that has an exponent of 0 is equal to 1. And there's a y behind that, and that's going to come up a little bit later in class. I love talking about the y. I'll give you a tidbit. I'll give you a little preview about why that is. Let's talk briefly about why. We'll see more about it later in class. Y is anything to the 0 power. Y is anything. I'm going to use a variable x. Y is anything to the 0 power equal to 1. X can, in this case, can be any number, right? Any number. What has to do with this? Watch this little pattern. 4 to the third is equal to, now what we think, 4 times 4 times 4, right? That's what we think. And we evaluated that a minute ago, and it was 64. Now what I'm going to do is write 4 to the second. 4 to the second is 4 times 4. Right? So one of these 4s sort of disappears, and that equals 16. Now I'm going to do 4 to the first. So another one disappears, and that equals 4. If you notice what's happening here to our exponents, same base, exponents, 3, 2, 1. Those are all decreasing by 1, right? 3 minus 1 is 2. 2 minus 1 is 1. Well, what's happening over here? What's happening to go to 64 from 64 to 16? We're losing one of these 4s. We're removing it's called a factor. Factors are things that are multiplied. We're removing a factor of 4, which is the same thing as dividing by 4. 64 divided by 4, 16. And then we remove another factor of 4. Same thing as dividing. And now we have 4. 16 divided by 4 is 4. So let's just now examine this pattern and say, go one more spot. 4 to the 0 is equal to, well, continue the pattern. We reduced our exponent by 1. So we take this number here, divide it by 4 again, remove another factor of 4. And what are you left with if you divide 4 by 4? 1, right? Anything divided by itself is equal to 1. So here you can see from a mathematical pattern, we love patterns in math, a pattern, we can sort of see the why. Why anything to the 0 power is 1. We're going to learn more about that, but that's just one of the patterns that sort of shows that. Okay, so that's all we're going to talk about exponents for now. See you next time.